Hello guys, we are back with our next lecture. In this lecture, let us go through the next concept. Okay, so that is instruction format, guys. Okay, so instruction format. So how the instructions are exactly structured is the question, right? Yes. So basically there are 5 different types, guys. So first one is a 4 address instruction format, 3 address instruction format, 2 address instruction format, 1 address instruction format, 0 address instruction format. So these are the total 5 types. Okay, so in simple words, these are really easy to understand, guys. So the thing is, you should concentrate for a few minutes. I think the video will be around 5 to 7 minutes maximum. That's it. Okay, please concentrate. So the first type is a 4 address instruction format. Okay, so with the name, what you understood, guys, there are total 4 different addresses stored, right? So first address is for operand 1, second address for operand 2, third address for result, fourth address for next instruction. So where is next instruction? That address is also stored. And the first address is for op code or mode. So basically op code is nothing but if it is addition, subtraction, division, multiplication. So how you can differentiate? So there you could give some representation, right? So if it is addition 0 0, if it is minus 0 1, if it is multiplication it is a 1 0, if it is division 1 1. So in that way you will give some bits. So the first bit is for op code. The second one is for operand 1. So basically if you ask me what is exactly operand, X. So this is nothing but operand 1, this is operand 2, this is a result, and this is the next instruction address. Got it? Yes. So now you got an idea, right? So this is the 4 address instruction. Okay. So the major advantage with respect to this is everything is clearly written, right? So there is nothing to miss here. So very simple, easy to use and easy to understand. But the major disadvantage is it is really lengthy, guys. So if your address bit, this bit is a 16 bits, so this will be 16, this will be 16, this will be 16. So it is really lengthy, right? It is going to waste more storage, right? Yes. So that is the major disadvantage with respect to 4 address instruction. Okay. So I have written an example also. So it is nothing but A is equals to B plus C. So the first one is opcode. So it is a plus B, C, A. And this is for your next address location. Got it? Yes. Okay. So the next second type is a 3 address notation. Okay. So what we have removed here is, so we have just removed the ending part. That is nothing but the next address. So we added opcode, operand 1, operand 2 and the result. So we have just removed the end part. Okay. Yes. So if you want, you can check an example. So basically, if this is our equation, how can we convert it into a 3 address mode, guys? So this concept I think we'll be covering in compiler designing, guys, or in theory of computation. So in any one of the subject we'll be covering most of these concepts, like exactly how you can convert. Okay. Yes. So how you can convert this is, so first let us do a plus b. So do a plus b and store in somewhere. Okay, and you perform C plus D and store it somewhere. At the end, in X, substitute this result, that is X into Y. So in this way. So in this way, if you write it with respect to memory and with respect to some registers, so that will be the thing. Got it? Yes. Okay. Yes. So the major advantage here is this is a better than 4 address, right? Okay. So why it is better than 4 address is, so whenever we are storing the next instruction address, so basically we are having a special register, guys. It is called as a program counter. So what is the goal of this program counter is, if you are executing X instruction, it is going to store the address of X plus 1. If you are running X plus 1, it is going to store the address of X plus 2. So in this way, it will always store the next address. So here, this field is waste, right? So that is why 3 address mode is a good one when compared to 2 address mode. Okay, sorry, 4 address mode. Okay, yes. So, but it is still lengthy, right? So because it is again having 40 plus 40 plus 40. Okay, yes. So the next type of addressing mode is 2 addressing mode. So we are having only operand 1, operand 2 and opcode. So 2 plus 40 plus 40. Got it? Yes. So if you take the same example, so how we can do with respect to 2 addresses, guys? So first you will take A from memory and push to R1. So again you will take this address, you will add it, you will write it. So in this way you can write it, right? So it's just a simple observation. So the only thing which you should remember is at any moment of time, only one memory operation should be there. That's it. Okay. Yes. Okay. And the next step is, okay. Yes. And the major advantage here is okay, sorry, I think I did not explain this two address mode, right? Yes. So basically what is two address mode? In that only two addresses will be there. So here we removed that destination part also. So 240 40. Okay. So here what we have removed, guys, we removed the destination, right? So that is the reason why we will use registers to store the data. Okay. So memory of A value, I will be pushing it to R1. So from R1 plus the memory B. So I will be pushing again in R1. So basically I am using R1 and R2 two registers here, guys. Okay. Yes. So this is a two address instruction format. Okay. Yes. I think we'll be discussing this anyway, like this exact instruction formats in compiler designing. So don't worry too much, guys, because at that time I'll be concentrating more on these representations. Now we are just understanding the structure. Okay. Yes. So the major advantage here is it is less in length, more efficient, number of registers low. Okay, so again here we are using only two registers. Okay, the major disadvantage is code optimization is relatively difficult. So here how many lines are there, guys? In total 1 2 3 4 5 6. So to do just a single small addition and multiplication, it is taking 6 lines. Here how many lines it took? It took 3 lines. So it is almost a double. Got it? Yes. So now moving on, the next type is a one address instruction. Okay, so we are having opcode and we are having operand. Okay, so 240. So we are using accumulator here. So basically what is accumulator is, it is a special purpose register which is going to store the values, guys, internally. So it is going to add the result, store the value. It is going to store the value normally also. So everything you will be using with the help of accumulator. Okay. So A plus B into C plus D. So first you will take A value, push into accumulator. You will add accumulator with this B value and push into accumulator. Again that accumulator value you will store somewhere in memory. Again you will take C value and store in accumulator. Again you will add accumulator plus memory D. You will again store in accumulator. You will multiply accumulator with this address D. So you will get the final result. So in this way, just by using the accumulator only, we are solving here. Okay. And the last type is nothing but a zero address instruction. So here the only thing which we store is opcode, guys. So for this, the best example will be with respect to stack. So if I want to perform A plus B into C plus D, so I can push one after the other and I can perform the operations, right? So that is nothing but a zero address instruction. Got it? Yes. So these things are really interesting and good with respect to the theoretical concepts, guys. Okay. Yes. So in the whole part of this lecture, I told that in the first slot, we will store mode or opcode, right? So what exactly is the mode? Like few of the students have got doubt, right? Yes. So that is nothing but instruction mode, guys. So there are almost around 9 varieties, I think so, 8 or 9 varieties of instruction modes, like how instruction could be stored. Okay, so that is what we'll be discussing in the next lecture, guys. Okay, yes. So I hope everyone got a clear idea with respect to the okay, so I hope everyone got a clear idea with respect to the instruction formats. So in the next lecture, let us discuss about the addressing modes. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.